What's up? What's up? What's up? It's your boy, the network. Today's topic is section 3.29, configure and verify OSPF for IPv6. This is a topic in the CCNP route exam code 300-101 version 2.0. It will be called the CCNP route or CCNP enterprise exam in the future. So this may or may not transition into the new exam. I haven't looked them up yet. Let's take a look at the exam blueprint, see where we came from or where we're headed. Again, implementing Cisco IP routing, exam code 300-101. This may or may not transition into the new exam, CCNP Enterprise. And we just wrapped up the section, configure and verify OSPF operations. Today we are going to move on to OSPF for IPv6. Then we're going to finally move away from OSPF and move on to the BGP section. But notice it says describe. Also says configure and verify, but it doesn't go that in depth because that would be more CCIE stuff. So configuring and verifying OSPF, we all know what OSPF is. It's a routing. I've said it for the past, I think, couple videos. We know what OSPF is. It's a routing protocol. It's open source. You can use it on any router that supports it. This is just the IPv6 flavor of it. What is IPv6? IPv6 is the new version of IPv4. What is IPv4? It's an IP addressing scheme that we use to hand out to computers because computers need IP addresses to communicate on a network. We ran out of IPv4 addresses and we're basically recycling with several concepts and tools such as network address translation, port address translation. We've done all kind of tools. We've done all kind of things to kind of recycle our IPv4 addresses. Now we're trying to transition into IPv6, and this is the IPv6 flavor of it. Let's go ahead and look at the slides for some more information. Okay, so first of all, we're going to talk about the commonalities that OSPF for IPv6, which is also known as OSPF version 3. OSPF version 2 is the version that's used for IPv4. Now, the things that is common with it is, as you can see here, it also uses protocol type 89. It's also a link state protocol, supports VLSN. What's that? That's variable length subnet masking. So that way you could use different IP addresses in different classes and stuff like that. The LSA flooding and aging concepts are the same. And it uses areas, same packet types. You remember what the packet types are, right? Link state advertisement, link state update, link state request, the hello packets, and also the database description packet. So there's 5 packets, just like EIGRP also has 5 packets. It uses the 32-bit LSID. I believe that's link state ID. I think they really meant router ID. Correct me if I'm wrong, but the 32-bit ID would be like the router ID. It looks like a regular IP address, right? Regular meaning IPv4. But in IPv6, we also use a 32-bit. It's going to look like an IPv4 address. You'll see when we launch up Boson NetSim. It also uses interface cost metric. There's also DR and BDR elections, so that's designated router and backup designated router. Those are the routers that manages the link state database. And then periodic reflooding of LSAs every 30 minutes. Here's what's different about it. We got several differences here. It uses the multicast address of this for all routers, FF02::5. So we're going to remember that. This is for DRs or designated routers. It uses IPv6 AHESP authentication. Remember, OSPF version 2, or the one for IPv4, uses MD5 hashing for authentication because we did that in the authentication video. Neighbors don't need to be in the same subnet. All other rules apply. And the most confusing part to me about what's different about the IPv6 version of OSPF is that they changed the names of the LSA types or the LSA types as if that was even confusing enough. Type 3s are renamed to Intra-Area Prefix LSA. So it's the same function as type 3. They just changed the name, really. Type 4s are called Inter-Area Router LSA. Very similar, but router. So 3s is prefix, 4 is Inter-Area Router. Right? It's the same function as type 4s for OSPF version 2. What's that? That's for IPv4. And then type 8 is a new LSA. So just to make it even more confusing, type 8 is for OSPF. It's called the link LSA. It's used to provide the linked local address to neighbors so it can be used the next hop address. So you know how you need to know the default gateway or the address of the next hop router? We use the linked local address, and to discover that, we use the link LSA. Type 9 is new also, and that's called the I don't know if that's right. I think that's supposed to say just Intra-Area Prefix LSA, or is that Intra-Area Prefix LSA? I might need to look at that, double check that, just to make sure that's not a misspelling there. But this is a type 9. It's used to send information about the router itself, subnet information, and attached stub and transit networks. These exist to make SPF recalculations not so disruptive. That's what's different about this and OSPF version 2 for IPv4. We have a config example right here, real simple. It's kind of similar. It's just that the first one, we use this to turn on IPv6, because remember, IPv6 is not turned on by default. This is very similar, except we just add the IPv6 keyword. We do router OSPF and then the process number. We have to declare a router ID. And IPv4 is done automatically, right? It's going to pick the highest loopback. If that's not available, the highest physical interface, that's up. And if that's not available, you just can't turn on OSPF. You have to have, there has to be an up interface somewhere on there, or else you'll get an error. I forgot what the error is, but I did it in one of my last videos. If you're a loyal subscriber, you'll see that. Then you go to the interface, and this is a lot easier. You don't got to worry about network statements. I love it doing it this way for IPv4 as well. You just do IPv6, OSPF, process number, and then the area key. You just the area number. You just got to go in the interface and do it. There's no network statements. You ain't got to worry about wildcard masks. This is much easier. So I know the long numbers for IPv6 kind of scares me, at least, but this is easier to even turn on IPv6 or OSPF for IPv6. Here is another family, address family example. I haven't gone too much on what address family is, but here's a configuration. If you can pause it, freeze frame it, you may have to do some extra reading on your own on what this is. I had just grabbed this information on journey2ccie.com, I believe it is. It's a blog that some guy had. He's working on his CCIE. And I haven't really gone over too much of this. I don't know. I don't think Boson NetSim goes over what address family is. Again, I may put some notes below for anything that's missing on. I haven't really put that much information on address families here. So once I get more research on that, I'll put it in the notes below. I usually say that in these videos, and I haven't been putting notes on them. But don't worry, I'm going to go back and watch pretty much all these videos and put missing labs and missing information that I might have said that I was going to put a link for. Here's some various show commands. It's pretty much the same thing as OSPF version 2 or IPv4. OSPF for IPv4. We just going to add the IPv6 keyword. That's it. See, show IP. Instead of IP route, we do show IPv6 route. Instead of show IP protocols, we do show IPv6 protocols, so on and so forth. Let's go ahead and fire up Boson NetSim and run this lab configuring OSPF v3 part 1. All right, so here's the lab we're going to be working with. Route lab configuring OSPF v3 part 1. I don't even know if there's a part 2 in this. But anyways, here's the topology we're going to be working with. It knows it looks kind of scary. However, we're just going to be working with, I believe, area 0, these 5 routers within this network here. So don't worry about this AS, don't worry about this or that. We're just going to be worried about the 5 routers in area 0 right here. Here goes some basic commands here. We already know about this stuff right here. Show commands that we discussed earlier. Again, we just need to worry about turning on OSPF, declaring a router ID, and so on and so forth. Here's the addressing guide. We can skip all of this. And task 1, OSPF. Enable OSPF v3 within area 0, right? So area 0, remember, of these 5 routers right here, right? In this task, you will configure OSPF v3 to share routing information between the routers in OSPF v3 area 0, which serves as the core of your company, blah, 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 blah. Let's go ahead and skip all this. Okay, so just know that it's process 600. OSPF requires the equivalent of an IPv4 address as a router ID, just like I mentioned right here. Uses 32-bit LSID. I know it says link state ID. He should have put router ID. It's a couple typos in here. So, but anyways, that's what we're mentioning here. To uniquely identify a router, and you must explicitly do it on this way. So it says here, can this router ID be generated automatically? No, just like we just said, because you have to explicitly define it. If so, what are the selection criteria that a router uses to generate an OSPF v3 router ID. I don't believe it does so. So I don't even know why they even ask us that. Before you configure a router, before you configure an OSPF v3 routing process on router 1, what features should you ensure is enabled on router 1? Well, obviously we need to make sure that IPv6 is enabled. On router 1, create an OSPF v3 routing process that uses process 600 and ensure that the routing process is enabled. So we're going to go to router 1, which is located here. Let's make sure IPv6 is enabled. You remember how to do that? IPv6 unicast routing. That turns on IPv6. Then they want us to use process ID 600 and ensure the routing process is enabled. So we are going to do IPv6 OSPF 600, right? And I don't believe we need anything else. Now we're in the process. We ensure that it's enabled, I believe, that way, right? What does the router ID need to be? Display information about the running IPv6 protocols. Did R1 automatically generate a router for the routing process? If so, what did it use for its router ID? I believe, let's see. Maybe I was wrong about that. Should do show IPv6. Do show IPv6 protocols. Oh yeah, there go to router ID right there. So we already had a, I guess it does automatically generate it. So it does, my bad. It does automatically generate it the same way it does for IPv4. So it did generate a router ID. My bad on that. What feature should you ensure is enabled? We did that. Process 600, as we did right there. So it is enabled. On router 1, identify all interfaces that connect to routers within area 0, and then enable OSPF v3 on those interfaces. So what connects to OSPF area 0? Let's see. Show IPv6 OSPF, maybe? That should tell us how many interfaces in this area. None so far. So maybe we need to do show IP interface brief. So we got only one interface, pretty much. 2.0. The other one is a serial interface. No, yeah, we got that one. Yeah, there is a serial interface that's also up, but all interfaces that connect within area 0. Well, we know area 0 is, I don't know any other way, but we're just gonna go ahead and do it with those two because we tried OSPF interface. Let's try it. Show IPv6 OSPF interface FA1/0 is not enabled, so we need to do that anyway. Let's go ahead and global config IPv or interface FA1/0 IPv6 OSPF 1 process ID area. That's what it is. We got to put the process ID. I wasn't paying attention. Was that up there? Yeah, it was up there. I believe that's it. Area 1, right? Is what we said? No, we said area 0. Process cannot pick a router ID. Why not? Please configure one manually. Oh, we meant process 600. Let's do that. See how we got that error? We need to do IPv6 OSPF 600 area 0. That should do it. We need to do the other interface, FA00 IPv6 OSPF process 600 area 0. So we did those, enabled the OSPF on those interfaces. On router 1, display information about the OSPF interfaces. So we are going to do what we were trying to run before. Show IPv6 OSPF interface. And now we can see FA00. We got an interface ID, we got a router ID, we got a link local address, and then here's the other one. All right, so verify all interfaces that on router 1 connect to area has been associated with process ID 600 and have been configured as members of area 0. So we did that by running that command. No. How do we verify that? Yeah, that's area 0. This guy is in area 0. We got process 600. process 600. What else they want to know? Process, the area, all interfaces that connect. Okay, so that's it. Router 2. Go to router 2. Ensure IPv6 unicast routing is enabled. Let's do that from the beginning. So we're going to go to privileged exec. Then we're going to go to global config mode. We're going to say IPv6 unicast routing. That turns on IPv6. Create an OSPF routing process that uses process 600. We said it was IPv6 router OSPF 600. That turns it on. It says here, cannot pick a router ID. Please configure manually or bring up an interface. I think that was the error that they want us to see right now. Enable OSPF on all interfaces that connect to areas within area 0. Let's see what interfaces we got here. Do show IP interface brief. There is no IPv6 or IPv4 address here. So on router 1, display information about the running IPv6 protocols. How we do that? Show IPv6 protocols. So as you can see here, router ID is quad 0. That's the problem here. That's why we got that error. On router 1, so it did not, it says here's the question too. Display information about the protocols. Did router 2 automatically generate a routing ID for the routing process? No, it did not. If so, what did it use as its router ID? It used quad 0 as its routing ID, as you can see there. On router 1, manually configure the router ID to quad 1 for the process 600. So we're going to go back to router 1. Where's router 1? Router 1 is right over here. And now he wants us to change the router ID. Right now the router ID is this. So we are going to global config mode. And we are going to say router ID is going to be IPv6. I don't think that's how you do the router ID. We're going to go to IPv6 router OSPF 600 router ID. They said quad 1. We have to notice it says here reload or use clear IPv6 OSPF process command for this to take effect. I believe we mentioned this in the last video. So let's go ahead and gather this and clear IPv6 OSPF process. We mentioned this in the last video, but that was for IPv4. We're going to do the same thing on router 2. What's router 2? We're going to do the router 2 and give him quad 2. So we're going to global config mode. IPv6 router OSPF 600, I believe the process was. And we're going to give it a route ID of quad 2. Now if we run that show IP protocols, do show IPv6, you can see now we have quad 2 instead of quad 0. To facilitate the identification of the routers in area 0 and to ensure that the OSPF routing process of each router can automatically create router ID, refer to the IPv6 address table and assign the appropriate IPv4 address to the loopback 0 interfaces on each router on area 0. So we need to basically assign the loopback 0 addresses on each router. So we need to go to router 1. We did that. We already did that. Router 2, we did that, right? Because when we did quad 1, quad 2. So now we can go to router 3 and do quad 3, but we're going to give it to loopback 0, right? So do we have any loopbacks on here? We don't. So we need to make sure we give the loopback addresses for these guys. So let's go back to router 1 and give him the loopback, right? Because I don't think he had a loopback. Did he? Show IP interface brief. No, he don't have a loopback. So we need to make loopback 0 quad 1. So interface or global config mode interface loop 0 IP address quad 1, and it is a /32, which is 255.255.255. No shut just in case, because this is a simulator and that doesn't happen automatically for some reason. Usually you would get an error, a syslog message letting you know that the loopback is up. We're going to go to router 2 and do the same thing. Let's get out of this. Interface loop 0. IP address is quad 2. I guess you can make the IP addresses the same as the router ID, but that's the same thing as IPv4, I believe. Let's do a no shut just in case. Router 3, same thing. Enable global config. Router, my bad. IP. Sheesh, what am I? I can't even think right now. Loop. It's like 3 in the morning right now. Loop 0. IP. That's no excuse because we gonna lab every day. Quad 3. No matter the weather. Don't ever come around here no more. 255.255.255.255. No shut. And we're gonna go to the same thing on router 4. I'm going to enable mode, global config, IP or interface loop 0. Give him the IP addresses, I believe it's quad 4. And yeah, we're going to do quad 4 and quad 5 respectively. Quad 4. No shut. And router 5, which is located here. Enable global config, interface loop 0. IP address is quad 5. 255.255.255.255. So we did loopbacks on each router in area 0. Assign the appropriate addresses on each router in area 0. So we need to, Jesus, we forgot to put them in area 0. All right, so V6, OSPF, 600. That's probably what we need to do. Area 0. No IPv6 enabled on this interface. So I believe we got to make sure IPv6 is enabled, right? That don't look like it's in our configuration table, but we're going to do that anyway because it says here no IPv6 enabled on this interface. So what if we do IPv6 enable and then run that command? That worked. So we need to make sure we put the rest in area 0. IPv6 enable, and we're gonna say IPv6 OSPF 600 area 0. Same thing with router 3. IPv6 enable, IPv6 OSPF area, my bad, 600 area 0. It didn't mention anything about that command right there. That's pretty weird, but let's go to router 4 and do the same thing. IPv6 enable, IPv6 OSPF 600 area 0. And then same thing with router 5. IPv6 enable, IPv6 OSPF 600 area 0. And just wake me up here. Configure router 3, 4, and 5 as members of area 0. Ensure that IPv6 unicast is enabled. And configure OSPF for process 600. Thought we did that, but whatever. Let's do show IPv6. Show IPv6 protocols rather. There we go. See, we got OSPF 600. So router ID is quad 5. Members of area 0, yeah, the loopback is in area 0. I don't know why what they're saying, they want the routers in members of area 0. I believe not the interface. They didn't specify interfaces, but whatever. Believe we did that already, but let's go work our way back and double check. Do show IPv6 protocols. He's running 600, quad 4 is his area, and then loopback is in the area 0. Not the interfaces, not those physical interfaces. Let's see what let's see show IPv6 interface. It's just show IPv6 OSPF interface. Okay, so we don't have no interfaces in running OSPF, huh? Let's just show IPv6 OSPF interface. Maybe we got to do those interfaces. Router ID. Let's look at the rest of this stuff. IPv6 unicast is enabled. IPv6 unicast routing. That could be why we didn't get that. We got that error though. That could be why we got that error. IPv6 unicast routing. Remember, I'm doing this for the first time. Did it generate routing ID? Yes, it did. Quad 5. Let's go to router 3. Make sure we did that. Router 4 is unicast routing. Router 5. Let's make sure we got unicast routing on here. IPv6 unicast routing. It says here, configure those as members of area 0. So how do we verify router 5 is a member of area 0? We can just do show IPv6 OSPF interface. So we don't have no interfaces. Let's put FA00 and 10, or FA00 and 01 in those in area 0. So we're gonna go to interface FA00 IPv6 OSPF 600 area 0. We're gonna do the same thing with 10 interface FA1/0. Was that 1/0? 0/1. 0/1. Do the same thing. We're going to do the same thing on router 4s. See, now they're coming up because they didn't tell us that they wanted a specific interface. They just said that the routers in specific areas. Here's the thing. You don't put routers in areas. You put their interfaces in areas. So that was a misleading question there. We need to do a router 4, the fast Ethernet 00 and 01, 00 and 01. So we're going to go to interface FA00. We're going to say IPv6 OSPF 600 area 0. We're going to do the same thing with FA1 0/1 IPv6 OSPF. We should see some neighbors come up very shortly. And router 3, we need to make sure we do the same thing on the fast Ethernet interfaces, which is 00 and 01. So on router 3, interface FA00, IPv6, 600 area, router, that's not it, OSPF 600 area 0. Do the same thing on interface FA0/1. We should have a neighbor come up very shortly here, and then we're gonna do the same thing on router 2 to make sure we get that. We did that already, didn't we? No, we did it on just loop back. So on this guy, we need to do it on 00 and 01. Interface FA00, and do that command, and interface FA0/1. Same thing with that command. Don't see what's so notable about it. Let's go check the answers and find out. 1B. Task 2, 1B. It's notable because there are 2 equal cost paths. How? I don't even see that. On router 1, examine the OSPF link state advertisement database. How many unique advertising routers are identified in the type 1 router LSA group? We do that with show IPv6 OSPF database. And he wants to know how many type 1s. Type 1 would be router links, right? Because type 2 is network. So we got 1, 2, 3, 4, 5. We got 5. Examine the type 2s in detail. Is one of the routers functioning as a designated router for more than one network segment? Let's see. We need to look at the type 2s. Type 2s are located. Here go to see. Remember, these LSA types are different now, right? So this is 1. This is type 2 right here. And they want to know how many unique advertising routers. No. Is one of the routers functioning as the designated router? Who's functioning as a designated router in the link state? Router 2, type 2s. I'm not too sure. It says count 2. Here's the link ID. It's most likely that guy. Just because he got, no, it's most likely this guy because he got the lowest age. No, it should be this guy because he's been up the longest and is usually the first one. Is one functioning as the designated router for more than one segment? Yeah, it looked like it's this guy because there's two. There's two quad ones. On router 3, display the OSPF neighbor table. Remember how to do that? Show IPv6 OSPF neighbor. How many neighbors does he have? We got 1, 2. What information is displayed to identify each neighbor? We got the interface ID 3 and 4. We also have a neighbor ID. So it's really the neighbor ID. So the IPv4 address. Does this differ from the way OSPF version 2 identifies neighbors? No, that's the same exact way. IPv4 identifies its OSPF neighbors through a 32-bit link state ID or router ID. Are there any neighbors, the DR or backup designated router for each network to which router 3 is attached? Are any of the neighbors the designated router or the backup designated router for each network to which router 3 is attached? Let's see. Show IP OSPF. It's not database. It's not neighbor. Interface. That should tell us who's the designated router and who's the backup. There it is. There it is. Backup designated is quad 3. Designated router quad 3. So basically router 3 is both. On router 5, display the OSPF statistics. How many times has SPF been run? So on router 5, that's an easy one. I know how to do that one by heart. Show IPv6 OSPF. Jesus. Show IPv6 OSPF. And we can see the SPF algorithm has been ran 16 times. Right there for area 0. We don't have any more areas, so it's been ran 16 times. On router 4, display information about the interfaces. What is the configured hello timer value for FA01? So basically we go to router 4. We only got 2 more questions after this and we can wrap this up. And we are going to say, get out of this, show IPv6 OSPF interface. He said FA, Jesus, come on, man. FA 0/1. And he wants to know, what is the configured hello timer? The hello timer is configured to be every 10 seconds. Considered dead in 40 seconds. 4 times the hello, right? 2 more questions, y'all. We wrap this up. No, that's it. That's it. That's all I got for y'all today. Sorry for not being too much entertaining, but I'm just trying to wrap these up and just race through these labs. So if you like this video, please comment, like, subscribe. That's my YouTube page. That's my Twitter handle. Go ahead and add me on Twitter. Make sure you subscribe, hit that notification bell so that way you know when these videos are coming out. Thank you for watching the network.